at that peak video quality, whereas the NR device 100% of the time is playing at that peak readout. And again, this was the 50th percentile device. But what if we start talking about the 10th percentile? It's not just about the median user or the peak user. It's also about that user that's at the cell edge or indoors. We're getting that 1 bar, it's 1 signal quality on here. So let's look at the 10th percentile device. So what you can see on this is even at 10th percentile, the 5G NR device is able to 100% of the time play back that video at the peak quality, whereas the LTE device has now dropped back down to that 480p. Let's do a download. So you're about to get on the plane, you want to download a 3 gigabit movie. Again, this is 10th percentile. You get 2 hours of HD entertainment in 4 minutes instead of 47 minutes. So that's a huge gap in user performance as far as if I want to get this before I leave, I'd much rather have it in 4 minutes versus 47 minutes. And this is an older LTE device. The other thing we're doing is we're continuing to evolve LTE because we want to push LTE as far as possible close to 5G, because as 5G gets deployed, it's not going to be everywhere day one. So you want, actually, when I move out of 5G coverage, that LTE experience to be as close as possible. So let's look at the most state-of-the-art LTE device, LTE Cat 20. And now you see, instead of a 10x difference in user experience, we're talking about still a benefit to 5G NR, but a 2x difference in user experience. Let's look at the other thing the tool does. It allows us to let's look at 90 percentile browse, and allows us to compare all the devices in the network. So this is bursty traffic. So you can see, you can almost see the evolution of LTE from the early LTE Cat 4 devices all the way up through LTE Cat 20, which is state-of-the-art. We just introduced our first Cat 20 modem. You can see it operating on the back wall back there. But what I wanted to point out is this step forward, this digital, big step forward with 5G NR sub-6 throughput, going from 280 megabits per second with the Cat 20 all the way up over 700 megabits per second with 5G NR sub-6. Again, this is 3.5 gigahertz. Not only higher throughput, but also significantly lower latency. So a lot of emerging use cases are, much more real-time interactivity, whether it's interactive gaming, interactive virtual reality, and so driving down, driving up the throughput, but also driving down the latency in the mobile network. And this gets us excited not only about existing use cases, but what else can we do with these mobile networks? One of the things that I like to talk about is, can we start, with these very high throughputs, very low latencies, can we start to augment the computation power on our devices with computation power in the cloud? Imagine actually in real time editing a video that's not local on your device, but out in the cloud. And imagine that experience on today's type of networks. Try to do that in this crowded type of environment. And that's what we see as some of the new type of emerging things that the app developers and the cloud service providers are really interested in when they start to look at the power of 5G. The only other thing I would point out on here is it's not just about performance, it's also about efficiency. So why we continue to focus on performance, we're also delivering each one of those bits in a much more lower cost manner. So utilizing these advanced antenna techniques and the wider bandwidth, we're able to deliver anywhere from 2 to 3x the spectral efficiency. So for the same chunk of spectrum, being able to deliver 3x the data, which is important not only from a user experience perspective, but also from a capacity and a overall OpEx perspective when you're talking about an operator. So this was Frankfurt. Again, we also simulated San Francisco. Again, this is